Hi everybody, welcome to the CERIAS Security Seminar here at Purdue University. It is my great pleasure today to introduce Aaron Massey. What you might not know is that Aaron actually was an undergraduate here at Purdue, so I'm sure that he's very happy to be back. He's currently a postdoc at Georgia Institute of Technology, and he's here today to talk about regulatory compliance software engineering. Aaron.
Thank you. And thank you for the opportunity to come and speak at the CERIAS Security Seminar Series. I was actually introduced to this series by my roommate when I was an undergrad at Purdue. He's now at Google and doing great things with JavaScript standards, so I think I would like to take the opportunity to thank him. This has changed my outlook, it's changed my career. It's one of the reasons I got interested in doing security research in the first place. So thank you, Alex. Today, I'd like to talk about regulatory compliance in software engineering. You didn't ask me here to talk about my roommate. This is a specialization within software engineering that focuses on how can we demonstrate as a part of the software engineering process that we're doing our due diligence and complying with laws and regulations. Okay? You might think this is well researched. You might think, well, we've been building software for decades. We've had laws for hundreds of years. Surely we've solved this problem. Actually, it has only recently become an area of active research in the software engineering community, probably in the last 7-8 years or so. So I'm going to go through a little bit of extra background on the ethics and motivation behind this. Then I'll define very briefly the fields, regulatory compliance software engineering, and dive real deep into a specific part of that field that I did for my dissertation research, legal implementation readiness metrics. That is, how can we make a decision about a requirement as to whether or not we're ready to move from the requirements analysis phase into design and implementation from a legal standpoint. So we'll ignore a lot of the engineering concerns and just look at the legal obligations and try to make that definition, make that decision at that time. And then hopefully I'll have time for questions at the end. So I'm going to start with a pop quiz. I've always wanted to give a pop quiz at Purdue, and here it is. Who is this person? Now, if you happen to know Latin, you might just be able to read his name to us. I don't know if you can actually read it, but his name is inscribed there at the bottom. This is, since I don't see any volunteers, this is Hippocrates. This is everyone's favorite physician, the inventor of medical ethics. He's well known for creating the Hippocratic Oath, which most people know because of the do no harm clause. But the Hippocratic Oath actually has another clause that's very relevant to anyone building a modern healthcare system today. And that's this one, the privacy clause. So all that may come into my knowledge in the exercise of my profession or daily commerce with men, which ought not be spread abroad, I will keep secret and never reveal. Privacy, very important in healthcare. You want to be able to trust your physician, give them all the information they need to make a decision about what your actual medical issues are. Trust is engendered by having this privacy clause. But we don't just rely on the ethics. Modern medical professionals still take this oath today. We don't just rely on the ethics of that situation. We also have laws and regulations. And there's historical precedent for that as well. The Code of Hammurabi actually had an engineering clause. So if anyone in this room or anyone watching the video is a civil engineer in ancient Babylon, if you were to build a house and that house collapsed, if it killed the occupant, you would be put to death. That's the legal punishment for building a house that's so shoddy it collapses and kills the occupant. Pretty severe, right? But it's actually a legal requirement. We've had long precedent for engineering in laws and regulations. And this now includes especially security and privacy laws and regulations. So sticking with healthcare and looking at a modern example of this, we have the Health Insurance Portability and Accountability Act. This was a law that ostensibly was designed to make sure that you could transport your insurance from one healthcare provider to another. Well, that transportation process needed to be secured, so they ended up actually defining a lot of regulations about how to secure medical information, how to keep it private, protect patient privacy. It's actually applicable to both electronic and paper-based systems, and the fines, the violations, are pretty severe. So it's $25,000 per violation per year for non-criminal violations. So this is not intended acts, this is just an engineering mishap, right? Non-criminal violations. And those penalties have only gone up since the act was passed in 1996. It's been amended recently, possibly best known by the High-Tech Act, which was President Obama's first initiative in his first term, part of the American Recovery and Reinvestment Act. This updated the penalties, made them generally more severe, added new rules for disclosures of PHI, and included data breach notification requirements. So the requirements are getting more complicated over time. Just as an example, they're starting to up the enforcement. The last couple of years, Signet had a $4.3 million penalty for a non-criminal violation of HIPAA. A couple of other companies have fallen into the same thing, same situation. So what is all, I mean, I know this is a little bit complicated. Let's try and back out and look at law and regulation from a little bit easier perspective. The perspective of a football player. Very, very basic. So I grew up in Indiana, and I suffered through quarterbacks like Jeff George and Jack Trudeau. When Peyton Manning came, we all thought he was the greatest thing since sliced bread. And he got injured in the spring of 2011, and everybody wanted to know, is he going to miss time? He was hounded by reporters, and he said, I don't know what HIPAA stands for, but I believe in it, and I practice it. And it's kind of hilarious when a popular NFL quarterback says something like that, but it should be absolutely terrifying if the engineer building your electronic health record system says something like that. They need to understand what HIPAA is. They need to know more than just what the letters are. They need to understand the legal obligations behind it. So that is the field of regulatory compliance software engineering. We'll define it as the application of a systematic approach to building, maintaining, and verifying software that must comply with laws and regulations. Society uses laws and regulations. Engineers have to comply with them. We need processes in place that help us do this. Okay, so software engineering has 5 essential steps. And I'm going to compare those steps to some practices in regulatory compliance engineering just for one aspect, the essential piece of it. Not necessarily for the ordering or anything like that. But I want to talk about what essential really means in software engineering. It means that you can't skip those steps. You can try to skip those steps, right? But the end result is not that you've actually skipped it, just that you've done a very, very poor job at whatever that step was intended to do, right? So in software engineering, you have requirements, design, implementation, test, and maintenance. If, for example, you were to try and skip the requirements phase, you might end up with a system that doesn't actually serve your end users' goals, doesn't actually solve the problems that your users are facing. If you were to skip the design phase, you might have a software system that is horribly designed, very difficult to use. You can't easily skip implementation, although I've definitely used software where it looks like they tried to skip the implementation phase, but that causes problems on its own. So all of these phases are essential. You can't really skip them. If you try, you're just doing a bad job of it. Same thing applies to regulatory compliance practices. So one practice in regulatory compliance software engineering is legal requirements elicitation or identification, right? You can try to avoid this, right? But then you don't know what your legal obligations are. You haven't identified them, you haven't specified them, you haven't actually taken them into account while you're building the software. You end up with a system that's not exempt from the law, it's still covered by the law, right? It just doesn't have a good concept of what the law is built into it. Same sort of thing for requirements, triage, and prioritization. There's a priority in the law. Sometimes there are exceptions that take precedence over other aspects of the law, what the law covers. If you don't try to model that, if you don't try to capture that as a part of your software engineering process, then your end system is going to result in a lot of violations of the law. So requirements traceability does the same sort of thing. For exhibiting due diligence, you really want to be able to show from requirements to design to implementation to test exactly how you were able to capture your legal obligations and ensure they were built into the system. That's done through traceability links. So you would take a traceability link from a requirement to some other software artifact, like for example the test that's built to test that requirement, and show that to a lawyer or somebody who's familiar with the regulatory process as this is how we tried to capture this in the process, right? The process of building our software. The last one, the one that I'm going to talk about most today, legal implementation readiness decisions. This is a decision where you've got a requirement and you're trying to figure out, have I covered everything that I need to according to the law, all of my legal obligations with this requirement or maybe with this set of requirements, because I'd like to get this iteration onto design and implementation and test and move it further through the software engineering process. So yes means we're ready to implement this, we've covered all our legal basis, and no means we're not ready to implement it, we need to refine further, we need to identify more legal obligations and do some more legal analysis, okay? We start that process with terminology mapping, okay? This is creating a traceability link from one term to another one term in a requirements document to another in a legal document. And it helps to have a common dictionary of terms, right? We really want to be able to speak the same language, have the same word represent the same concept. Because lawyers do not speak technobabble, engineers do not speak legalese. We really want to have a common glossary. This is the first step in building that traceability link. And there's even some nuance here. So on the left-hand side, I have a requirements document term. On the right-hand side, I have a legal hierarchy text. These are both actor objects, so they're both actors in the hierarchy. And the requirements document talks about surgical residence. So the system already has kind of got this concept of what a surgical resident is. You might try to map that to some actor within the legal hierarchy. It might best be described as a surgeon, right? Just based on the exact definitions of each of those things. But in the legal hierarchy, you also would have to inherit anything higher than surgeon in the text. So there's another concept, the medical professional. Your surgical resident might indirectly map to a medical professional. So whenever the legal text talks about medical professionals, you as a software engineer have to understand, oh yeah, that's actually also going to apply to all the surgical residents that we have, okay? That's the basic idea behind the terminology mapping, which is really the first step to establishing a traceability link. Now that's not the whole process, and I'm not going to really be able to discuss all of the rest of it in detail. I did just want to give you an overview of this chart, an overview of the process. So it's got 4 phases. The first one is the one we just talked about, doing a terminology mapping. The second one is further requirements identification and disambiguation. Because you're already going to be analyzing these documents, you might as well use established requirements engineering techniques to disambiguate and identify any other additional requirements you can find. The third step is elaborating that requirement with all of the legal priority, origin, and precedence information that you can find in the legal text. And then finally, you are able to trace from the requirement to subsections within the legal text, and you get your traceability link at the end of the day. If you're interested in this and you want more information, please contact me after the presentation. There are actually several opportunities, several ways that you can build a traceability link in requirements engineering. So I'm happy to discuss pros and cons, but that's not the focus of the talk today. The only reason I'm mentioning this is it is a necessary first step before you can start looking at legal implementation readiness decisions, right? You have to, at a minimum, have a set of requirements, a legal text, and a mapping from those requirements to the relevant subsections of the legal text before you can start making a decision about whether or not the requirements are actually meeting their obligations. So let's talk a little bit about legal implementation readiness. We're going to define it. We're going to say legal implementation readiness is a requirement that meets or exceeds its legal obligations. It's all of its obligations under the law. And this is often a question of interpretation and disambiguation. So there's this hilarious Dilbert cartoon where we have an engineer saying, there's 11 different ways to interpret the vague assignment you gave me by voicemail. But given the risks of choosing and my engineering oath to do no harm, I thought it was ethical to just do nothing. Right? And then the pointy-haired boss says, well, hold on a second. You could have asked for clarification. And the engineer's, oh, I don't know. That sounds risky. Right? This is exactly the situation we want to avoid, because engineers are put in this position where they have to interpret what does the law actually say and have we met those obligations. We want to support them. We want to give them evidence to stand on so that they can ask their boss for clarification as to whether or not we can proceed to the next step. So let's look at an example of how this might work. On the left, we have a requirement. This is for iTrust. iTrust was an electronic health record system that's developed as a pedagogical example at North Carolina State. And it was developed explicitly with the intention of complying with HIPAA. Okay? So they're considering legal implications from the outset in the building process. And this requirement says that iTrust shall generate a unique user ID and default password upon account creation by a system administrator. Fairly straightforward engineering requirement. And we have traced that requirement using the process I give you a really brief introduction to these 2 subsections within HIPAA that are displayed on the right. So subsection A1 that talks about access control, and subsection A2I also on access control and implementation specifications. Okay, so this requirement seems to meet both of those obligations, right? It assigns a unique user ID and default password. It seems to be able to implement the technical policies described there. So we're going to say this is legally implementation ready to go ahead and implement this requirement. So let's look at one that's not, something that would not be legally implementation ready. So in this case, the requirement says iTrust shall allow an authenticated user to change their user ID and password, right? So we're violating that second relevant HIPAA section there that says you have to have a unique name and password, or unique name or identifier, right? If you change your user ID, and that's the only identifier you have, then you can introduce conflicts. You could end up having multiple records in the access control system, whatever auditing system you have. So this would no longer be implementation ready. Okay, we wanted to know, because this seems kind of like an easy question, we wanted to know, how do engineers actually make these decisions? Can we assess how people look at legal implementation readiness right now? So we designed a case study. And we had 32 graduate students that participated over multiple sessions. All of these graduate students had some background in software engineering. They'd taken a software engineering class. And further, all of them had taken the graduate level requirements engineering class at NC State. So although they are software engineers in training, they're in graduate school, they may actually have more training for this particular task than some professional engineers. There's actually a common saying that everything we know about human psychology is based on surveys conducted of freshman students at universities that have taken psychology courses. This is the same kind of thing. We're still studying students. We understand there's limitations to it, but these are trained students and they've been focusing on these problems for some time in class. We also had 3 subject matter experts, one of whom was a lawyer who's been working in this area. The other 2 are software engineers with lots of experience in policy. And we just developed 8 legal requirements metrics. I'll go ahead and show you those later in the presentation, but I wanted to mention it up front because they are part of the study. We had 31 requirements, all from iTrust, the system that most of the students were familiar with from their graduate coursework. And the text of HIPAA section 164.312. Those are the 2 big inputs. So we've got the requirement set and we've got the legal text. We also provided a traceability matrix, the tracings from the requirements to the legal text. We did choose this section of HIPAA for a couple of interesting reasons. We were very familiar with it. We've analyzed it many times before. It focuses on technical measures. So if the students are going to have good intuition on any section within HIPAA, probably it's the one that talks about technical stuff, right? We picked the best, most technical section we could find, and it's complete. It's a whole section. We didn't have to cut up things and remove parts of it. So let's look at the questions we're trying to answer with this study. I actually had 6, but I'm probably only going to have time for the first 5, so I'm going to limit the discussion to those 5. The first question is about the subject matter experts. We wanted them to develop a consensus opinion, but we also wanted to know, before even trying to develop the consensus, how much did they agree? Just doing the assessment on their own, making the decisions on their own, how much agreement did they have? Then we did this with the graduate students. We had them each individually fill this out and decide whether or not they were able to come to some agreement. We were able to assess their accuracy using the expert consensus opinion as a gold standard against which we could measure. And then we started looking at the metrics. So the first 3 questions are about the human subjects, and the last 2 questions are about the metrics. Can we predict using the metrics whether requirements are legally implementation ready or not? And then finally are the categories themselves, and we've divided them into some categories I'll talk about in a moment. Are they accurate? Do they actually measure what we think they're measuring? So the first question, is there consensus among subject matter experts? Just walking into the room before they start the consensus process, do they already kind of agree on this? We found moderate agreement. So we used Fleiss Kappa to measure this. Had a Fleiss Kappa value of around 0.5, which is moderate agreement, prior to even discussing to try and resolve issues and come up with a consensus set. There was also universal agreement on 19 of the 31 requirements. So this indicates that there is some intuition already in the expert opinion about these requirements. Is there consensus among the participants, the graduate students who are doing the study? Well, we found very slight agreement with our Fleiss Kappa. This is only somewhat better than if you were to do random guessing for each of the requirements. So it's a binary decision. Yes, it's legally implementation ready. No, it's not. Fleiss Kappa is a statistical value that tries to take randomness into account. And we found only slightly better agreement than random. So let's look at question 3. This is the big one. This is accuracy. Can graduate students accurately assess? Well, we've got 30 or so answers. We need to find a consensus answer that we're going to define as the answer for the students. We decided to use 50% voting as a cutoff for the status of whether or not it was legally implementation ready. And I do have a follow-on study that I'll talk about in a minute that addresses this. And we found that students are more likely to miss requirements that are not legally implementation ready. So in this case, they're willing to say, yes, let's go ahead and implement it, when in fact there's actually probably other legal obligations you should have addressed before implementing it. And we have measures for this. We're using sensitivity and specificity rather than precision and recall because we are particularly interested in exactly this question. We want to make sure that we are not missing, at the very least, the ones that are not ready to be implemented yet. We're not saying that we can go ahead and implement them when in fact we should be doing more legal analysis. And we found a very low specificity, which indicates that they really are more likely to be incorrect on the ones that have a severe penalty. Okay? So now I'm going to introduce the metrics, and they're all based on intuition about legal texts. And that is that they're hierarchical. So even if you don't know the words, even if it looks like gobbledygook, like this example here, you can infer some meaning of the law based on the hierarchy and maybe a couple of other keywords, some easy to code for, easy to identify terms like except when or a section reference, a cross-reference within the law. On the left, that typography text has the same kind of structure that you would see in a traditional legal text. And I'll be using this as an example throughout because it does help us show that just the structure alone can give us some intuition about what the text itself might be saying. So these are the categories for the metrics that we had, okay? And they're all based on answering an individual question. So the dependency metrics help us answer the question, are there dependencies or potential dependencies between the requirements themselves that have not yet been identified, right? So the higher your dependency metric, the less likely you are to be legally implementation ready, okay? The complexity metrics do the same sort of thing for complexity. So are the current requirements too complex to be implemented according to what we've got in the law? Maybe we only map to one high-level section of the law and we don't get any of the leaf nodes within that hierarchical structure. The maturity metrics are actually meant to counteract complexity metrics because sometimes there only are high-level sections within the law, where the only way that you can map a requirement is to a very general, broad legal requirement, like you must implement reasonable security measures, right? It's a very high-level requirement that you might commonly see in a policy document that would otherwise, if we did not account for that in the metrics, score very poorly, right? So this is the counterbalance to that. The dependency metrics, there's two of them. I'll give an example of subsections mapped on the next slide. We wanted to find metrics that were very simple, very, very simple to start out. We didn't want to overthink the problem. We really just wanted to come up with the simplest possible way we could model dependency. So we decided to count the number of subsections that have been traced, that are mapped by each requirement, and identify all the cross-references. Because those two seem like intuitively they might introduce dependencies into the system. Subsections mapped in particular, this would be a really quick way to calculate it. You can see this is very simple. We have a description of a requirement. And again, we don't really need to know what the requirement itself says. So we've got more typography text there. We just need to know where the mappings are, how that mapping process worked. And there's two, so we'll say that metric has a value of 2. Complexity metrics, we have 4 of these. Again, we're trying to be as simple as possible. We don't want to overthink this. So the more words, the more complicated, right? The number of words is a good way to count this. The more sentences, the more complicated this is going to be, right? The subsections count, right? So we're using subsections mapped in the previous one just as a raw count. But in this case, we want to recursively count all of the subsections beneath the ones that it's mapped to. And I'll show an example of this on the next slide as well. And then we just wanted to count the number of exceptions, because the more exceptions you have, the more exception cases you have to handle, the more complicated the requirement is going to be. So subsection count, here's our quick example. Now both of these are leaf nodes, right? Section A1, there's nothing beneath that, it's a leaf node. Section A2II, nothing beneath that one, that's also a leaf node. So our subsection count here for this example is 2. But if instead of mapping to A2II, maybe the requirement were mapped to A2, then the subsection count would have to include the children for A2, and you would end up with a value of 4. Okay? Very simple metrics to try and calculate this. Then finally, we have maturity metrics. These are the 2 maturity metrics we came up with. They're a little bit more complicated. The first one, subsection depth, I'll have an example on the next slide. This refers to the deepest level subsection that you map to, subtracting the total number of subsections that it maps to. Okay? So the idea behind this is that you want a small number of leaf nodes that each have one and only one requirement mapping to it. You really don't want to have requirements that map to a lot of high-level nodes and then maybe one low-level leaf node. Okay? Subsection fulfillment percentage is kind of based on the same idea. You really want to have an entire requirement set that's mature if all parts of the legal text have some requirement mapping to it. So you perform the mapping, and for all of those subsections that your requirement maps to, if the rest of the subsections in that part of the legal text have requirements, then you end up with a very good fulfillment percentage metric. And again, the higher your maturity metrics, the more likely you are to actually be ready to go into implementation, right? So it's different than the other two. The higher dependency and complexity, the less likely you are to go in and implement them. So here's the example for subsection depth. In this case, we're using the same requirement, the same legal text. The deepest one is highlighted, that's A2II, and we already have the subsections mapped from earlier. Very simple calculation. We end up with subsection depth 1. Okay, so we use statistical modeling to be able to actually get the answer to the question, right? We all want to know, is the requirement legally implementation ready? We used these metrics, found correlations, and built a statistical model that can predict whether or not it actually is. So it's logistic regression based on the subject matter consensus opinion, and we use tenfold cross-validation to get a really good model that we can use for prediction. So what were the results for this model? Well, the logistic regression model actually exhibited fair agreement. It's not quite as good as what the experts were just walking into the room. We've got a kappa value of about 0.35, but it's definitely better than what we got from the graduate level software engineering students who were doing the same task individually without the metrics. And we had sensitivity value and specificity values both not great, but certainly okay. In particular, specificity, remember this is the one we care about more because it's the one that we could really have problems, right? If we implement something that's not ready to be implemented, we've got high costs to go back and fix that problem later on. So we really want a high specificity, and the model does that. It's more likely to miss LIR requirements rather than to make a mistake about those non-legally implementation ready requirements. Overall, this shows that the modeling can be useful. The metrics themselves can actually help us make these decisions. So the categories, right? We're talking about those categories. We want to make sure that each category actually does trend in the direction we intended for it to trend. And we did a test for this as well. So we were looking at the coefficient sign on the logistic regression model that we built. We were expecting dependency and complexity to have negative and maturity to be positive, and we actually did see that when we looked at the model for the data. So if the coefficients were different, then we would have had some conflict between the individual requirements in each category that prevented it from accurately telling us, yes, the higher your complexity, the more likely you are to have some other problems that you need to look at and find in the legal text. Okay, so that problem that we had that I was talking about, the 50% voting that we were using, we really wanted to address this, right? Wideband Delphi works great for the expert consensus decision-making process, but it's not designed for 30 or more students. So we had to find a smaller group of students that we could use Wideband Delphi with and get a consensus opinion. So we don't want to be unfair. We don't want to model it just using voting alone. We'd like for them to have discussions and come to some form of agreement as to whether or not the requirements are actually legally ready to go, ready to be implemented. So we did that. We ran a study, and this is question 7. Are they able to accurately do that using wideband Delphi? It mirrors to question 3 from before. While we were doing this study, we also thought, let's look and just see what's the extent of the discussion. Are they like really going back and forth on some requirements? Do they just completely agree with no time at all elapsing on others? We wanted to see just what does the discussion look like. So we asked that question as well. Well, here's the case study design. 14 graduate students, a lot less than 30, but still this is pretty big for wideband Delphi, which normally limits at around 12 or so. And all of the participants had a similar background from our previous study. They'd taken software engineering, they had taken requirements engineering class, and had some training on regulatory compliance issues. And we used the same requirement set, same legal text, same terminology, same traceability mapping. And for each requirement, we asked the participants to either come to a unanimous decision that it was legally implementation ready, or come to a unanimous decision that it was not legally implementation ready. Well, we didn't want the discussion to go on forever, so we also set up the rule that if you can't decide, we're going to fail gracefully, right? We're going to say it's just not ready if you can't come to a decision either way. So those were the rules we had set up beforehand. We had 2 sessions to do this. Took about 2 hours or so to actually come to consensus on all 31 of the requirements. So for question 7, are they able to accurately assess whether or not the requirements are legally implementation ready? It turns out they're not that great at this. They ended up basically having the same level of agreement with the experts that they did before, but in exactly the opposite direction. So before, we had a really high sensitivity and a really low specificity. And now that they're doing this in groups, we have a really low sensitivity, not quite as low as it was, as the specificity was in the previous one, and a really high specificity. So this is encouraging in some sense, right? It does at least say we're not failing on the side that we have real serious legal penalties, but we're now failing on the side where we have higher engineering costs because we're really overthinking the problem, where a legal expert would say, no, you're ready to go, you've got your risk appropriately assessed. These engineers, because they don't know, working in groups, are now very conservative. Whereas previously, if they were making the decisions individually, they were very liberal. They were willing to say, yes, let's go ahead and implement this. So it's very interesting to see that changed that drastically when they went from working individually to working in groups. The last question, question 8, what was the extent of the discussion? Well, again, we had that fair agreement. This is somewhat better than they did before, but it's not as good as the logistic regression model we built using the metrics, and it's definitely not as good as the experts that we had. So a kappa value of about 0.25, that's fair agreement, better than random, better than they had before, but still not as great as we would like to see. So I'm going to summarize fairly briefly the contributions that I've presented here. 1, the empirically evaluated methodology for tracing, actually getting the traceability link from a requirement to the actual legal text. That, I think, is a very important part of the problem. I wish I had more time to go into that, but please come and see me or ask me questions about this in the Q&A session if you're interested. Then we demonstrated, this is really critical, graduate students are not really well prepared to do this with any level of confidence. These are entry-level engineers. They haven't really been trained in some of the domain-specific aspects, so at the very least, this means if you are working, building software in a legally regulated environment, you need to have a training program in place, because anybody you hire right out of college, or maybe even from other firms, doesn't really have the kind of expertise that's needed to make legal implementation readiness decisions. And actually, there's a colleague of mine from NC State who just had a paper accepted at the Requirements Engineering Conference, kind of demonstrating that professional practitioners that are already building these systems are struggling to the same degree at making these decisions about legal questions. And then finally, I described our 8 empirically evaluated legal requirements metrics. They actually can be used to help estimate LIR decisions. I think it's something that could give you something to stand on when you go to your pointy-haired boss and ask that question that you were afraid to ask about legal implementation or legal obligations. So hopefully people will find that interesting. There's a couple of areas of interesting future work for those of you who might be interested in the field at large, but not interested in requirements engineering or legal implementation readiness. I do think that traceability to other software artifacts is critical, right? If you're trying to build something that has to comply with law, you are not just looking at requirements. You should also be looking at code, source code, the tests that verify you've actually built your system properly, even your maintenance procedures to make sure that your maintenance is going to maintain that legal compliance over time. Very important area for future work. Personally, I'm interested in trying to automatically generate those traceability links. There's been a couple of studies that have used some machine learning algorithms to try and take expert opinion, build a model that can actually find the traceability links without going through that giant ugly flow chart I showed you earlier, to do all of that automatically. It would be kind of interesting to do that. The one in bold here, using natural language processing methodologies to actually improve the metrics and improve our ability to make these sorts of decisions. That's what I'm working on now at Georgia Tech as a part of my postdoc. We just recently had a paper accepted from the regulatory side of this. So if you were a regulator working at the FTC, the Federal Trade Commission, and you were interested in who are the egregious actors or what are some particularly challenging privacy policies, this might be a good way to find them from the thousands and thousands of privacy policies that are out there. And then finally, other empirical studies of software engineering practitioners. We really don't have a whole lot of data about how these decisions are actually being made out in the field. So that's a great area for future work if you have the ability to do that. For those of you who might be undergrads, I wanted to give you some big picture takeaways because this is really a young interdisciplinary field with lots of research opportunities, and I would encourage you, especially if you're interested in security and privacy, to start thinking about the regulatory implications because there's a lot of laws and regulations out there now. I think most legal professionals are starting to realize that we really should start regulating this stuff on its own, separately, and try to focus on some of these hairy issues that really are not well handled by the laws that we have on the books. So software engineering graduate students, they're ill prepared to make these decisions. That's another really, really big takeaway. Entry-level engineers just should not be in that position. Anything that you can think of that might improve that situation would be a big, big future hit in research. And then finally, you have to involve a lawyer, right? Whenever I start talking to a crowd of lawyers about this research, they get a little bit nervous. They get concerned. Are we trying to replace lawyers with some sort of technology that makes all the legal decisions for them, for us? No, we're not. We really aren't. And you can tell that just by looking at the data. The expert opinion was way better, way much more agreement than any of the other options that we had. So you really need to have legal expertise. And if you're a practitioner in the field today, and you're building something that's regulated and you haven't consulted a lawyer for some of these decisions, I would encourage you to think about it very strongly because there are some sensitive issues here. So thank you. I'll be more than happy to take questions now if you have any. Yes.
Question. So it seems to me, however, that even being able to judge whether the requirements are ready for implementation is very subjective.
Oh, absolutely.
So at the end, that's I think makes the problem difficult because even the second example that you give about the users being able to change their login, for me that would be ready to implement because any CS student knows that identifiers have to be unique. So we don't need to tell them anything else. Whoever even will create the account initially will have to check that the login name is unique.
Right, yeah.
So, so a lot really depends on the implementer as well, because, if this is implemented by somebody who is very expert on the implementation in that area, probably things are ready to be implemented.
Yeah.
And sometimes the policies, as you said, are very wrong or are very incomplete. So lawyers should really write better their policies.
Right.
It's not all the fault of the engineers.
No, it isn't all the fault of an engineer, absolutely. And it's a great question because this is really the crux of the issue. This is one of the reasons why we had to have an expert opinion in the first place, because it is subjective. The whole idea of whether or not you've met your legal obligations is going to be a subjective opinion. So we wanted to make sure that we were comparing it to what expert opinion would be, not to some absolute that we've arbitrarily identified. The example that you brought up, the second slide that I had, I'll see if I can actually go to it really quick here. We used that as a part of the tutorial that we provided to all of the engineers that were participating in our study. So we actually asked them another question, a follow-on to this one, as a part of the tutorial. So we gave them the two examples. We walked through an example of what is legally implementation ready and what is not, and then we asked them this question. Right? We've got this requirement. iTrust shall allow an authenticated user to change their user ID and password. If we add the phrase to the end of that requirement, as long as it remains unique, is it now implementation ready? Whereas previously it was not. What do you think? Is it, if we add that phrase, does this requirement suddenly meet all of the obligations that are outlined there?
It fails the tracking user identity.
Exactly, right. It does fail that. And a lot of the students that were in that situation initially reacted as, oh yeah, it does, because we were worried about this uniqueness property, but there's this subtlety where actually it does kind of fail. You can no longer uniquely track everybody. So some of these decisions, they are subjective, right? And there's going to be mistakes along the way.
Yeah, but again, there are, because, of course, when you develop software, you take into account a lot of requirements, not only the legal ones. So whoever builds software today knows that accountability is important.
Right.
So I would have accountability anyhow, even if I didn't have any legal requirement.
Right.
So it could be that those requirements come from some other requirements. So at the end, it seems that perhaps they should be given a set of all the requirements and not single one, because otherwise.
Oh, I'd love to run that study. Yeah, I would absolutely. I mean, that is certainly a limitation of this. We only looked at legal requirements or requirements that had legal implications. We didn't really consider some of the other engineering things that would come into the process if you were dealing with something that was an engineering complexity, purely an engineering complexity of how you would maintain legal compliance through that. So it is a simplified study, a simplified look at the problem. But at the same time, we really wanted to be able to get at the very base minimum, give some students, some engineers, the most technically oriented section of an actual genuine legal text that we can find, give them a set of requirements on which they can make these decisions without spending days or weeks of development time, and just see, how are we doing, right? This should be the easiest possible scenario, and we still didn't get very much agreement. We still got fairly poor results.
Today, we have a lot of techniques like aspect-oriented programming and various ways in which you can automatically enhance code. So which means that sometimes not all the requirements to be explicitly in a way addressed by the software being developed.
Oh, sure. And there's different ways of actually stating a requirement, right? So you might be using UML as your requirement source. You might be using some other requirements notation. There's a couple of different popular ones in the requirements engineering community. We really haven't studied this. We were just sticking with the simple natural language requirements. I think there could be a lot of work in that area to see. Maybe aspect-oriented programming does really make these decisions easier.
Question, the kind of different flavor of question, have you looked at other countries' legal systems and whether your metrics are still applicable? Because the U.S. tends to have very prescriptive laws. Other countries, much less so. Do your metrics still work?
Well, I guess I would say I'd push back a little bit. In the privacy community, where I do a lot of research, European laws are often viewed as more prescriptive generally. So they have general privacy laws for data control, and they're very prescriptive about them. Whereas in the U.S., sectorally, so healthcare or your video rental records, or maybe email, which hopefully we're going to get an improved law for email privacy here soon, you'd have maybe prescriptive in one sector and not prescriptive in another, right? So I would just push back briefly on that. But I would say the community at large is definitely looking at that. One of my colleagues from the same school, NC State, now at Carnegie Mellon, is looking at jurisdictional issues, multiple jurisdictions, in requirements compliance, absolutely. And we go to a lot of international conferences where people are very interested in this. I guess the other thing I would say, for these metrics in particular, we don't have an issue because both systems still use a very hierarchical, rigidly defined structure for their actual legal texts. The only real difference is, I think, for the U.S., there's 12 levels deep. If you start for the very top of the U.S. Code of Federal Regulations, start going down, you get to 12 levels deep or so. In Europe, I think if you start at the top and go down, it's usually around 8 or 9. Depends on the country. But it's still hierarchical. Other questions? Oh, come on now. Surely someone has another question. Yes?
So you mentioned, or there were oaths that engineers had to take 1700 BC.
Right.
About, basically it was the engineer had some fault when malpractice occurred.
Right.
We have that some today with more medical side.
It's not limited to medical. No, there's a code of ethics for the ACM, the Association of Computing Machinery.
Yes, sir.
There's a code of ethics for the IEEE. There's a code of ethics for the National Society of Professional Engineers. Pretty much any major professional engineering organization has a code of ethics that's fairly explicit about the law. The ACM code of ethics is very interesting because it actually has a clause in it that says something to the effect of, you as the engineer cannot pass the buck to the law. Sometimes the law, from an ethical standpoint, is wrong, right? And you as an engineer have an ethical obligation to violate the law and do what is ethically right. Very, very interesting clause in the ACM Code of Ethics. But from an engineering professional standpoint, I don't know of any professional organization that does not have an explicit code of ethics that says we want to try and uphold the law of the land.
Right, that may be in place, but when a computer science engineer out in the field makes this mistake, usually the burden doesn't really fall on them when they make a
Right.
huge mistake.
Yeah.
While in other communities, like medical communities, they're,
Right, so I
They
may have
directly
misunderstood
get
your
sued.
original question. The answer that a lot of folks have for that is certification, right? So in other fields where ethics are really important, like medicine, like law, where confidentiality, again, is very important, there's an association that certifies you before you can work in that field. So if you do something unethical as a lawyer, you might get kicked out of the Bar Association, and now you can no longer practice law. There's nothing like that for engineers, well, for software engineers, I should say. And there's a lot of folks saying that's the best reason to implement one. Yeah.
I mean, there are some areas where contracts essentially require an NSP, a
Right.
professional engineer,
Right,
someone who is NSP certified.
right. Yes, exactly.
So,
And it's kind of challenging to do that from a software engineering standpoint because most of the exams that you have to take to pass to become a professional engineer are focused more on traditional engineering disciplines like civil, mechanical, and so forth.
we don't yet have an equivalent in computing, and
Exactly.
there's a lot of debate over whether we should or not.
Yeah, well, the field is very young, and I think the people who are arguing against the measure have some really, really good points because we don't really know what software engineering is, right? Is it science, engineering, art, craft? It's very hard to define exactly what makes for an engineering process in software, but yeah,
How long have they been building buildings before the Code of Hammurabi came along?
that's a great question. Oh man, I wish I could tell you the answer to that, but it was probably hundreds of years. I mean, gosh, the pyramids were around long before Hammurabi wrote his code of ethics.
Maybe in a few thousand years, we'll be ready to have it.
Any other questions? All right, well, thank you very much. It was a pleasure to be back at Purdue.